Hello, I'm Miles from Technical Art Applications. This is my rig and retopology. First, let's speak about the retopology and what decisions were made within the design choices. The model was made for a mobile 3D person perspective run and jump minigame. The model wouldn't be seen from the front and only twisted at small angles to change the course of the path, a kind of temple run style game. This was why my retopology was designed to look very nice from the back. Due to the design choices, the rig was created with this aspect in mind, a simple and easy control design. So let's talk about the back first. The IK spline was created with a cluster to easily control the components with a curve. They were split into two different clusters, the lower back cluster and the upper back cluster, and controlled with a couple of control curves. The scale of the model was constrained by a scale constraint to the main control at the base of the feet. This means you can easily control the scale of the whole model without losing the controls or the model's integrity. Let's talk about the head now. There is a control for the head, which is for the orientation of the head itself. There is then a control for the neck, which is connected to the head and are used for the rotation of the head to the neck. Okay, let's quickly go over the arms of the model. To start from the shoulders down, there is a clavicle control at the back of the shoulder to control the orientation of the clavicle joint. It is constrained by an aim constraint. An IK was created from the shoulder to the forearm. This was done to affect the shoulder and the elbow joint without affecting the wrist joint. I then created a control for the wrist, which would affect the orientation of the wrist and its movement with a point constraint. I then created an elbow control connected by a pole vector constraint to the IK handle. This allowed twist orientation of the IK handle based on the movement of the wrist control. Okay, let's talk about the legs and foot now. An IK plane solver was connected from the hip to the ankle to create movement of the knee. I then used a single chain solver from the ankle to the ball and then another one from the ball to the toe of the foot to solve the foot behavior when moved. A control curve was then created for the control of the leg movement. I then created a knee control to easily orientate the orientation of the knee when the legs are moved. At the base of this model is the super mover control, which controls all controls and is easily rotated and moved with the model intact.